Hello, everyone. Thank you for taking time to watch my video. Today, the topic that I like to talk about is time series forecasting using deep learning and focusing on the LSTM RNN model. Um, what it stands for, without further ado, we jump right into introducing what it is. LSTM stands for long short-term memory, and RNN, as we know, for recurring network. And on the next slide, we'll see um, what the regular RNN is all about. Here, on the top diagram, it's a representation of the RNN model for every time step, where X is our time series data. So X can be, say, uh, Dow Jones index level, or it could be, say, stock price of Nvidia. And X zero, that can be the zero meaning today, for example, the price of Nvidia today. X one is the price of Nvidia tomorrow. X two, price of Nvidia the day after, and so on and so forth. And H here, denoted by H, it stands for hidden state. And that's what makes RNN special. What we mean by that, before we go on, is A for activation function. Um, so back to what makes a recurring neural network special is it's able to feed this hidden layer information to the next time step. And this is how the RNN is able to retain memory of past time steps in the second bullet point here. And if we drill down and expand and look at what the activation function is, here we have a 10H function. So uh, here on this slide, essentially it's a high level summary of what a regular RNN model is. On the next slide, here we see the difference. What makes LSTM different from RNN? So LSTM is actually a type of RNN, but what makes LSTM different is it has not just one activation function, the 10H we saw on the previous slide, but there are three gates. Uh, that makes it able, the three gates together makes the LSTM able to better retain key information over a longer period of time. So here, the three gates are a forget, an input, and an output. So forget is just going to read out here is that it decides what info to drop out from the current time step, and the input gate uh, decides what info to update and send to the next time step. So the output gate actually controls the flow of information to the next time step. And the last bullet point here talks about the concept of vanishing gradient. So I like to explain in words what that means. So when it comes to RNN, LSTM model, and in training, there's the concept of propagation through time, BPTT for short. So what we know about backpropagation is, in mathematical terms, it's a partial derivative. It's a partial derivative of the loss function at every time step. And as we know, the loss function is, by definition, simply the predicted value minus the actual value that gives us a loss function. And when we take the partial derivative of the loss function, that's how we get the gradient at every time step. So as we backpropagate and in training, um, mathematically, what it means is taking that gradient, multiply uh, o, as we go back in time. So for example, let's say the gradient is 0.5 for argument's sake. So if we go back in time, two time steps is like taking 0.5 to the power 2, we get 0.25. And for the LSTM and the RNN, where the activation function is like a sigmoid or 10H, we know value can be pretty small. So using the illustrative example of zero point 0.5, it is reasonable. So if we go back in time, backpropagate 10 time steps, it's taking zero point 0.5 to the power of 10. So we know right away it will be a very small number by the time we go back in uh, for time 10 time steps. So apologies if I'm not very clear in explaining, but essentially that's the vanishing gradient problem. Like a regular RNN, um, the gradient goes to zero very quickly as we backpropagate in time. And uh, loosely speaking, the regular RNN model forgets quite quickly. This is where LSTM is uh, more powerful than the regular RNN because we, LSTM model is able to use the three gates that we talked about here to essentially control what to forget, what to remember, like to as in send to the next time step. So it's better able LSTM is better able to retain information over a longer time period. So excellent technique for forecasting time series, especially over a longer period of time using like more historical data points. So I I will stop here in terms of explaining at a high level what the regular RNN and the LSTM model is all about, and to jump into an actual use case where we're looking at the unemployment data published by the Federal Reserve Bank of St. Louis going back to the 1940s. For the purpose of this use case, we are looking at in this graph data going back 10 to 15 years, so around 2010, 2011. What we see here, the blue line, is the actual data that is used for training to predict the red line, which is 12 time steps going out to the end of uh, 2021. Data monthly, so every time step is 1 month. It's a monthly data set that we're looking at. So visually, we can see that over time, uh, unemployment rate is trending down. So we were to feed a straight line. We kind of see that like 10 to 15 years ago, it was between 8 to 9%. And by the time it was December of 2019, it's about 3.5%. In every year, there's a seasonality associated to this data set. It goes up, it goes down, up and down. So the going up, uh, in this time series, correspond to the holiday season, uh, which is a Christmas season and year end, where there will be hiring of more temp staff to man the malls, the retail malls, for example. And a question that came up during the teaser presentation in lecture earlier this week is, and it was a great question, why the red line looks rather flat? Sure, it's able to forecast a downtrend, but um, the red line is not capturing the seasonality as well as it should have or it should be. So we can touch on that. We will touch on that later when we look at the notebook. But for now, we see that this is how the red line is how LSTM model does the forecasting for 12 time stats ahead using historical data going back 10 to 15 years. But of course, on the next slide, we all know then came COVID. So it's a black swan event represented by the dotted bright blue line here, where unemployment spiked. So uh, the 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 reason why I had wanted to present this slide, this graph is uh, and it's my opinion is that whether it is deep learning approach using LSTM, using RNN, or whether we use a more traditional approach, statistical approach technique like ARIMA or SARIMA, as for seasonal, it will be difficult to forecast and predict a black swan event such as COVID, as we see in this chart. And but a question we can ask ourselves is so if we use LSTM model, is there a way that we can better capture the evolution in time, right, of the actual data set? So one way to do that is to retrain and do forecasting just for one time stat ahead as new data point comes in. So it's my bad I didn't include in this chart the training data. I actually use 12 data point going back to January of 2019 to do the training and to forecast just one time stat ahead, which is the red line here. So the forecast using the training data is about 4.1, 4.2% represented by the red line here in January of 2020. So then when the actual data represented by the bright blue line came in, it was 4%. So pretty close to each other. And then we will take the 4% actual data, which is the new data point at in time, and use that to train the LSTM model again to forecast the next time stat, which goes down to slightly to 3.9%. And we repeat this over time. And that's what, in essence, is the second bullet point to allow updates with the rolling window to continuously train the LSTM model with new data. So this is one way we can better capture uh, through time the evolution of the actual data. So somewhat like overlapping lines, the blue and the red line. So that's one way to use LSTM to forecast just one time stat ahead as new data comes in. Without further ado, let's take a look at the actual code in the notebook. So I'll switch screens to the notebook here. We are looking at in the first code chart. Yeah, we're reading in the data, and I'll share it. I'll zip it up and also upload to Canvas the data set in CSV format. And that's what the first code chunk essentially is doing. The next code chunk we can touch on and address the question that came out in class towards the end of the presentation is essentially in conversation with ChatGPT, it was recommended to use this pretty simplistic model where we see there's just two layers and there's a dropout of zero point 0.2 in between and followed by the dense uh, layer here to essentially do the prediction. So one way we could do better is to enhance this neural network by introducing more layers, for instance. And another way is to increase in training the number of epochs. Right here, we see that is just 50, like 50. And top of my mind, those are the two things I can think of to improve in this code, such that hopefully the seasonality will be better captured uh, by the red line, the forecasting, the forecasted, the predictions represented by the red line. Quickly, I'll go back to the slide. Apologies to be jumpy. Right here. So hopefully, the seasonality will be better captured in this graph by improving, enhancing the neural network and increasing the number of epochs while in training. So that, um, by and large, is what this code chunk is all about. The next code chunk essentially is just to plot it with the actual historical data, which is when COVID came. Finally, we will look at the code chunk, the last code chunk where it talks about the rolling window using the LSTM, and as every new data point comes in, let's go back and retrain the LSTM network. So it's essentially what the last code chunk is doing. Um, and um, Looking at the time, it's almost at a 15:15 mark. So I'll quickly just jump to the last slide, which is the conclusion. In summary, 4 bullet points. The first one, LSTM is an extension of a regular RNN model. Second bullet point is that LSTM is using those three gates to help better control information and retain information over time, over longer periods of time. Third bullet point is that is in my presentation, um, I'm presenting it in how LSTM can be used for time series forecasting, but it's actually used in other arenas such as natural language processing and speech. Finally, was and it relates back to the good question that was brought up in class is how to improve right, the forecasting capability of the LSTM network. Is here we have two bullet points that we saw was implemented in the code was through the dropout layers to reduce overfitting and using a rolling window to continuously update the model LSTM model as new data point comes in. So as it comes in, we're using one time step ahead to do the to retrain and to do the forecast for the next one time step ahead, time step ahead rather. So that's it for my presentation on time series forecasting using deep learning with a focus on LSTM model. Thank you for hearing me out, um, and that's it.